Greetings, Panthers. It's Dr. Augustine. I hope you guys are doing well. Today we are going to cover the topic of mass percent composition and calculating the mass percent composition. So one of the things we can do once we learn how to calculate the formula mass or the molecular mass of a compound is we can ask the question, how much of a compound is due to a certain element? And typically that's reported in mass percent composition. So if you had 100 grams of the stuff, how much of it is nitrogen, how much of it is carbon, how much of it is oxygen, etc. So that topic is called the mass percent composition, sometimes also just called the mass percent of an element in a compound. This is in section 3.9 intro, composition of compounds. We're just going to do one example here. Once you have an idea how to deal with one example, you should be able to take a look at many other examples. So let's take this compound right here. And the question is, calculate the mass percent composition of each of the elements in the following compound. N2H4 subscript 2 SO4. Okay, this is an ammonium type compound. It's got a sulfate group on it. And we want to find out the percentage due to nitrogen, percentage due to hydrogen, percentage due to sulfur, and percentage due to oxygen. What I'm going to do is I'm going to show you how to do one of these elements. And then I'm going to encourage you to stop the video, see if you can calculate the other elements, and then you can start the video again, and I'll just jump to the end and show you what the final numbers are. So anytime you hear the word percent, what should be entering your mind is percent is always a part divided by the whole, and then times 100%. So in this case, the part is the amount due to the element, and the whole is the total mass of the compound itself. And then, of course, it'd be times 100%. All right, so the amount due to the element, total mass of the compound, where do those come from? So the easiest way to do this is to think in terms of moles and to say, if we found the molar mass of this compound, that will give me the total mass of the compound. If I had 1 mole of this, that would tell me the total mass. And then I can find the number of moles of each particular element. So let's start with the molar mass of this compound. We'd have to look up most of these, but we have 14.01 grams per mole, grams nitrogen per mole, times there are 2 times 2, there's 4 nitrogen atoms, plus 1.008 grams hydrogen per mole. And there are 5 times 2, so there's actually 10 hydrogen atoms, plus sulfur is 32.07 grams sulfur per 1 mole. I apologize, I'm going off the screen here. And oxygen is 16.00 grams oxygen per 1 mole times 4 oxygens. All right, so if we add all those guys up together, we end up with a total molar mass of 162.19 grams N2H5 2SO4. That is the total mass that we talked about up top. That's this guy right here. All right, what about the amount due to each element? Let's just pick one element. We'll work on the nitrogen first. So the mass contributed by nitrogen is going to equal to 14.01 grams nitrogen per mole times 4 nitrogen atoms. In other words, this is equal to 56.04 grams per mole, grams nitrogen per 1 mole of this stuff. All right, so my percent by mass of nitrogen is just equal to the part divided by the whole. So the part is 56.04 grams per mole divided by 162.19 grams per mole times 100%. And that turns out to be 34 0.55%. Notice we have 4 significant figures here, 5 significant figures here, so my answer has 4 significant figures here. Okay, so this is a good time to stop the video, try calculating the other ones, and turn it back on, and we will we'll summarize. All right, we're back. So this was the first calculation we did. We found the number of, the amount of nitrogen that's involved, 56.04 grams per mole. That comes from the molar mass times 4 nitrogen atoms. Divided by the total is 34.55. We do the exact same thing for hydrogen, sulfur, and oxygen. We get 6.215% for hydrogen, 19.77% for sulfur, 39.46% for oxygen. We have 4 sig figs for all of these. And if you notice, if we add these up, we end up with 99.99%. Doesn't quite come out to 100% because of rounding or whatever, but that's a good check to see if you did it right. If you have to do all of them, they should add up to 100%. So your whole compound is made up of these 4 things, and these are the different percentages. All right, so we have found the mass percent composition for all the elements in this compound, and this is the general strategy for doing that.